So now that we finished talking about equations, how to solve them, and everything, now we need some motivation of why we even did that. And the best motivation I can give you are word problems slash applications. So some of these you might take as useful because you might see this in the real world, and some of them, it's very important skills to even just learn. So we'll start with the very basic one right here. A prepaid cell phone company charges $18.75 as a monthly access fee and 7 cents per minute of calling time. What will be the monthly cost? What will the monthly cost be if you make 179 minutes of calls this month? So I don't expect you guys to initially know how to do most word problems, but the key thing I want you guys to think about when looking at word problems are what are the key words. So let's look at some keywords. So the first thing is it charges, charges $18.75 as a monthly access fee. So this monthly access fee, if you notice that the final question says what will be the monthly cost. So that means this is only charged once. It's a flat rate. It only happens once. I don't have to worry about it doing anything. It just happens once. And then the next thing you need to look at is you're paying 7 cents per minute. The word per, the word each, they all mean the exact same thing. So if we're actually writing this out, and look at this, our variable per minutes, but we also need to know how much it's going to cost for 179 minutes. So we need to use some placeholder and eventually fill in that placeholder with 179 minutes. So our variable will be m. Say our variable m stands for minutes. So m minutes. M is going to represent minutes. So if I'm writing an equation, first let's write the equal sign. If I'm writing an equation, I gotta figure out what my flat rate is. And in this case, if you have a flat rate and and other prices are growing via multiplication, then we're gonna call this a linear function. That's exactly what a linear function is. If you think about the word problem itself, a cell phone company, how it charges, it is very linear-like. So my flat rate is $18.75. Well, that only happens once this entire month. We're only asking for the price for the month. So if we're only charging that in a month, then that is our flat rate. It only happens once. So we're adding this one time only. However, for every minute, we are getting charged $0.07 or 7 cents. This means that, hey, this guy right here, I need to eventually multiply it by something. So you want to think of that as the coefficient. I need to multiply it by the number of minutes. So why not just throw an m here? It's going to be your coefficient of your variable. Well, now we already have our setups. The only thing left is, hey, we need to solve this, but I don't know what m is. Or do I? If I look over here, they tell you that there's 179 minutes. So I'm going to plug that in. And when you plug things in, make sure you use parentheses to notify multiplication. 18.75. And if you calculate this out, this is going to turn into, what is that? 12.53 plus 18.75. So your flat rate is $18.75, and the price for the minutes is going to be $12.53 for 179 minutes. However, we need to combine them because the flat rate did happen. So in total, we're going to be charged $31.28. And I hope this helps for linear problems. Using the word each, using the words per as synonyms, it can help you out. And generally speaking, those are going to be your variable attached to your coefficient. So be on the lookout for that. Figure out what's your flat fee, flat rate, or whatever is being charged one time only. So that covers our linear equation. Now, sometimes you might not get a linear equation. Sometimes these word problems expect you to have some knowledge or history. In this case, this problem right here. Candy and Tim share a paper route, so they're mail delivery. It takes Candy 70 minutes to deliver all the papers, and it takes Tim 80 minutes. How long does it take the two when they work together? So if they're working together, how long should they take? So intuitively, students will make this mistake. They'll do 80 plus 70 divided by 2 gives 150 over 2, because 2 people, of course. Give you 75. So don't think it takes 75 minutes. That is not how it works in the real world. In the real world, when two people work together, it happens much quicker. It's not just going to be the average. It just does not work like that. So you're missing a lot of important details. So first off, you're missing the rate that they're doing, the distance that they're covering, and the time it takes. So you need to understand that, hey, when we're talking about distance, the distance is equal to the rate times your time. Using this, we can solve for the rate because I have the rate. It's telling me it takes 80 minutes to finish. It takes 80 minutes to finish delivering that paper. So in 80 minutes, they're able to cover this distance. That is your rate. So your rate, we got to solve for rate. We got to divide both sides by t. And then if I solve both sides by t, divide both sides by t, I get the rate is equal to distance over your time. Great. Your rate is equal to your distance over time. Now we can actually work with that. So the distance they cover, let's say Candy is, let's call Candy's rate 1, and then Tim rate 2. And that's going to give us rate 3 when they work together. So that's the generic thing, but now we need to actually go into what our rates actually are. So the rate is equal to distance over time. Well, the distance that Candy traveled, let's call it little d. And then the time it took her to cover that distance is 70 minutes. And then if you look at Tim, he covers the exact same distance. So it still should stay the same variable, it's the same distance. However, his time was 80 minutes. And then our goal is to figure out in the same amount of distance, how much time did it take for both of them? So we got to figure this out. Oh, hopefully this looks familiar. These are fractions, so we should know how to solve fraction. Well, we got to get common denominators. I got to multiply this by 80 over 80. I got to multiply this by 70 over 70. If I do so, I get 80d over 5,600 plus 70d over 5,600. And this is all going to be equal to d over x. And I do a single d here because I want to figure out in that same distance how much both of them can cover. I'm not doing 2 times d, 3 times d. No, it has to be that same distance for both of them. So I have this. Great. I need to solve for x. That's going to tell me how long it takes for both of them in that same distance. Well, once I have the same, fraction or denominators, I can add the two fractions together. So I'm going to get 150d, 70 plus 80, combine like terms. 5,600 equals d over x. Well, there's multiple ways to do this. You can multiply both sides by the denominator and solve for the numerator, or some people, when they see this, they like to do something called cross multiplication. Cross multiply. If you cross multiply this, let's just show that real quick. You should get 150 dx equals, because that was in the middle, 5,600d. And then to solve for this, to solve for x, you divide the term here. There's only a single term, so you have to divide here. So you got to divide 150d. If you divide both sides by 150d, the d's cancel out over here. You have x is equal to 37.333 with the bar over it. So what does that mean? That means for that same distance, it's going to take them 37 minutes. Oh, it's 37 minutes. Now, do we ever talk about minutes in decimals? No. So we got to multiply 0.333 with the bar over it, or 1/3, 0.33, times 60. Why do I multiply by 60? We got to figure out what is that in terms of seconds. And in terms of seconds, that's going to give us around 20 seconds if you round it up. 20 seconds. So it should be 37 minutes and 20 seconds. Remember, this is a decimal, but because we're in terms of minutes, and I don't like working decimals in minutes, I want to turn it into seconds. You multiply that by 60 because 60 seconds are in a minute. Boom. And you should get around this. It's not exactly, but We're not going to round down or anything like that. That's too ridiculous. So that's how you actually calculate it. So when you're doing these distance and time problem, you need to actually write your rates correctly. Most of the time, you are not using the same fraction. You're not just going to be averaging them together. You got to find a common denominator and work things out. So, and of course, this is only if they're moving in a very linear fashion. But we're not going to talk about that at all. So, now, next question. So this is a time question. So this is a distance and time question. So now we're moving on to number 3. A man who is 6 feet tall wishes to find a height of a certain 4-story building. He measures its shadow and finds it to be 28 feet long, while his own shadow is 3.5 feet long. How tall is the building? This is a very common kind of question that you'll see. You'll see this in trigonometry. You'll see this in calculus. Now, they'll take it further, a step further, and give you less information. So this is the start of that. So if you're able to have a strong foundation, you'll be able to work with those problems in future math courses because this kind of application does appear a lot. So I'd recommend drawing a picture first. So we have a man. Let's say Bob. I don't know what his name is. He or she, I don't care anymore. We have a person. And then we have a building. This is the building. Now, he wants to find out, let's say he, for now. He wants to find out how tall the building is. And I don't know how tall it is. However, he is 6 feet tall. He is 6 feet tall. 6 feet from here to here. He's 6 feet tall. And his shadow, or he measures the shadow of the building to be 28 feet tall. Boom. His shadow, however, is going to be 3.5 feet. So the goal of this is to somehow use something in math that you might see in trigonometry. And if you know anything about trigonometry, it's all about triangles. So what we're going to do actually is draw a triangle. These two triangles are similar, meaning that they're proportional. So what that means is that the relationship between the man size and his shadow is the same relationship as the building size and its shadow, assuming that he calculates his shadow the same time he calculates the building shadow, which is kind of impossible, but yes. So he is 6 feet tall and casts a shadow of 3.5 feet. So his ratio between him and his shadow, ratio means divide, is 6 feet divided by 3.5. However, with similar triangle, there's a property that tells us this is exactly equal to the ratio between the building shadow and the building's height itself. So we don't know the building's height, but we do know the size of its shadow. It's 28 feet. Now this is very similar to our time problem when we have a fraction equal a fraction. All we have to do is cross multiply. So if we cross multiply, we have 28 times 6 equals 3.5 times x. And if we calculate that out, what should we get? We should get 28 times 6. We should get 168 equals 3.5x. And divide both sides by 3.5 because this is a single term and it's multiplication. So you get x is equal to, what is that, divided by 3.5? 48. And now you're not done yet. You still got to tell me what this actual solution represent. So up here you got to say 48 feet tall building. Boom. That is the relationship. So if you notice, the shadow is almost half the size of the man. So it makes sense that the building should almost be, or the shadow should almost be half the size of the building. It makes sense. All right, moving on to the next question. So this is I guess you could call this a shadow question. Shadow proportion. I call these proportions when you have to do ratios. Now we move on to the stuff that I like a lot, working with rectangles. So the first thing you need to know about a rectangle is that, hey, this is very important, especially when you're talking about area. That's the key word, area. Area is equal to length times width. You need to know that. Write that down or something. So it says here the length of a rectangle. So I'm just going to read it off. I'm going to say the length of a rectangle, which is L, is, this is a key word. Whenever you see is, Generally speaking, that's going to be the equal sign. Is means equal. If I say x is 5, that's the same thing as saying x equals 5. So L equals 8 feet more than twice its width. So we're going to say 8 feet. Now, I understand that when the people see the word more than, they think of the greater than symbol. And it does mean that. However, there's a second meaning to the word more than. If I say I'm 2 feet more than, let's say, a water bottle or something. I don't know. That was a bad example, but I'm 2 feet more than this other person. That means I'm adding 2 feet to his height. So you could think of this as addition. So 8 feet more than means plus 8. 8 plus twice its width. The word twice, so 8 plus. So more than means plus right here. 8 feet more than means 8 plus. And then twice, well, that just means double. So I'm going to times it by 2. Times whatever by 2. And it says twice its width. It's saying 2 times W. Boom. So we have that. Great. That's what length is equal to. If the area of the parking lot is 120 feet, what is the width? This is supposed to be the word width. I apologize. What is the width of the fence? Spelled width wrong. So our area is 120 feet. We're going to be using this formula. Well, this is what length is equal to. I don't know what width is. The question wants me to figure out width. However, I know the area is length times width, so I can rewrite this as 120. That's what the area is, equals length times width. But notice that length is this guy right here. I can't deal with the problem with two variables. That can be difficult. I would love it if I could treat the problem with only one variable. However, this is very nice because I don't need to use L. I don't need to use that at all. Instead of using L, I can use this portion and plug it in for L because that's what length actually is. I don't need to worry about it. And let's see what happens if we do that. Then we're going to have 120 equals 8 plus 2W times W. Well, now that I've done this, I only have one variable to work with. The goal should be using only one variable if you can. If you can, I recommend it. Now that should be clear to what to do. You got to factor it. Oh, not factor. I'm sorry. You got to distribute it out. So now we have 120 is equal to 8W. Oh, I'm going to rearrange the terms. So we're going to have 2W squared plus 8W. I just moved them around. You would have had 8W plus 2W squared, but I wanted to switch it for a reason. Now this is a quadratic because we see the degree 2. So if you look at your quadratic, I would love to factor it if possible. But to factor it, I need to set it equal to 0. So let's set it equal to 0. I don't know if this is factorable or not. Who knows? So I got 0 is equal to 2W squared plus 8W minus 120. Oh, is this factorable? Who knows? Well, now that we have that, how can I factor this out? This is a trinomial, but before we even look at it as a trinomial, what do you notice about all the terms? There's a GCF. So I can rewrite this as 2 times W squared plus 4W minus, what is that, 60. Are there any factors of minus 60 that adds up to 4? Well, you have 10 and negative 6. So I can rewrite this as 0 is equal to 2 times W plus 10, W minus 6. Boom. Now, this 2 is multiplying, but it does not affect anything at all. As long as one of these giant groups are 0, then we have found the solution for our width. So in this case, width right here is equal to negative 10. Because if I plug in negative 10 plus 10, I'm going to get 0. And 0 times any number is 0. That's the beauty of this. The 2 does not affect anything. And then if I plug in 6 here, then I get 0 as well. Well, now I have 2 solutions for width. But this is a word problem. And when we're talking about the width of a fence, which one do I not want? I definitely don't want this guy. I definitely don't want this guy because it's a negative number. You don't have negative measurements in the real world. So your width is only 6. And 6 what? 6 feet. Because that's the problem we were working with. So width equals 6 feet. Boom. So we just solved a question that had a quadratic. This is a quadratic type question. Quadratic word problem. And you only know that because while you were working with it, you had to multiply the same variable twice. Now, it's very beneficial if you turn the problem into one variable. So that's another goal you should be having when you're working with these problems is can you turn this into one variable instead of two? Moving on to the next one. Was that all the problems? I'm pretty sure I had more. How do I go to the next one? I think I zoom out possibly. What was that it? I know I had more. Something's wrong. Where's my other? Huh. I don't know where my other problem is. Well, let me just insert it again. The file. Okay, home. Ah, my connection's bad. Huh. That's unfortunate. Let's see if I can fix that somehow. Refresh. So I apologize for the delay, but that's the price with technology, unfortunately. And I hope that you guys don't have issues when doing homework assignments or anything of the sorts. It should be down here. File, insert printout, downloads. Oh, where's it at? Desktop. I don't know where it is. Where's my file? Well, if this doesn't work, then let's go over here. Let's go up here. And then we'll go into this is supposed to be 1.7. I titled that incorrect, so I apologize. But might have to re-download this file. There we go. I downloaded it, and now let me go back on here and let me upload it. File. Oops. Let's do insert. Now it doesn't want to play with me, right? File. PDF printout. Downloads. There we go. Now it's available. Boom. So now I have the other problems we can work with. So there was about 2 more left. Set picture as background. Alright. So now this one right here, we've covered number 4. Now we're going to move to number 5. Let me zoom in for you guys. Boom. So I apologize for the delay. I hope that you fast forwarded till we got here. So suppose I folded a rectangular paper by X inches on the top, bottom, and both sides. Once I folded it all the way, the new dimensions of the paper turned out to be a 6 inch by 5 inch. Write the expression for the area of the original paper. So what it's saying is that I have a paper. Boom. And I did some folds to it. So boom, 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 boom. I did some folds to it. In particular, my folds, boom, 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 are going to be from the top, bottom, sides. And each of these are being folded by the same value, X distance. X distance here. X distance here. And X distance here. Right? They're all X distance fold. Now, the new size of the paper is going to be 6 inch by 5 inch. So I got to figure out what the area of the original paper is. Well, how can I figure how long this guy is? Huh. I know that this is also x over here because they carry over. They're the same. They're parallel. They're the same size. This is also x. So I have the original from here to here is 6, and the two ends are x amount. So that means the length of this guy is going to be 6 plus 2x because there's two x's I have to add. And then the bottom piece is going to be 5-inch. Well, this is also an x, and this is also an x. So it's going to be times 5 plus 2x. And now I just got to multiply it out to get the area, because area is length times width. So if I multiply this out, I get, let's see, 30 plus, what is that, 12x, and then plus 10x plus 4x squared. So if I actually organize this out over here, I get 4x squared, combine like terms, these are my two like terms, plus 22x plus 30. That is the area, that's the expression for the area of the original paper. So it's important you draw a diagram of some sorts. Try to imagine the folds themselves. It is very helpful. Now, when I did my paper, I drew the original paper and then I drew the folds. If you try to draw the folded paper first and imagine the original paper, it can get very tough to think about. So I'd recommend you do so, or do this instead. And then the last type of problem before we end it off is a simple interest formula problem. So now I am stressing this. However, you are going to learn eventually later on in pre-cal that there is a better way to calculate interest. This is simple interest. There's a lot of assumptions that are made. In particular, your interest is over a year. They say annually for a year. So we have, let me erase this all. It's in a way now. I have the simple interest I equals PRT. We need to know what each of them mean. T means time in years. Years. R means rate in decimal. Decimal. P means principal amount. That's the money. I is interest. That's the money you made for the interest. Determine an interest gain from a $1,000 deposit over a 3-year period at an interest rate of 5%. So let's just write these values out. T, R, P, I. We don't know what I is. We don't know how much interest we made. I know the percent interest, but I don't know how much money I made from that interest. P, that's your principal amount, principal. And when I say principal, it's spelled like this. So this is $1,000. That's the money you start off with. R is your rate. It says 5%. Well, I got to turn that into a decimal. It doesn't stay as percent. I got to turn it into a decimal. How do I move percents to decimals? That's a strange one. Well, to do that, you're going to move it 2 decimals over. So if you have 5%, you're going to move this guy right here, 5, 2 decimal places. So this is where your decimal should be located at. And then everywhere else you fill a 0 in. Boom. So so let me fix this up. So boom, boom, boom. And then this implies your dot's going to be here. So you have 0, 0, 5. Here's your decimal. I didn't want to put the percent on there. That would be too confusing. So your rate in this case is 5%, which is also 0.05. Your time it took, or the time of your interest rate of developing, this is a simple interest, so it's only happening once a year, is 3 years. So now all I do is just got to plug everything. I is equal to P, which is 1,000, times 0.05 times 3. And then what is this going to give you? This is going to give you, what is that, $50? I want to say $50. Is it $50 or $500? Let's see. Times 0.05, that's $50. So it's going to be $50 times 3 years. Am I drawing? Why is it not drawing? 50 times 3 years. There you go. is going to be how much interest you made in total. So that means your interest is going to be $150. That's how much money you made over those 3 years with a 5% interest rate. So that's pretty good, actually. So it's important that you think that, hey, I need to understand how to transform percentage to decimals. And even though we're covering simple interest, understand that later on down the road, we'll cover a better or more efficient interest formula, a more efficient one. It's going to involve another variable that you might have never heard for, but the other version, we're able to not only calculate using the rates, time, principal, but we're also able to account if our time is not in years. If instead we're compounding semi-annually or monthly or even weekly, if that was crazy enough. So that covers it for that problem. And I think I covered all of the word problems that I liked a lot for this unit or this section. So that covers it for 1.7. So I will see you guys later at 1.8. Take care. Bye.